And so in looking at one of these problems, let's try page 307, number 38. And I'll read it to you. You may want to follow along in the book on page 307. It's a little fuzzy on the notes. The difference between two numbers is 5. The sum of the larger number and twice the smaller number is 14. Find the numbers. Remember that this is practice plus. We're going to be translating. And because we're in the chapter on systems of equations, we can expect that we're translating into two different equations. And in this case, each sentence will translate to an equation. So you have the first equation, the difference between two numbers is 5. We'll call those two numbers x and y. Difference means to subtract, and when they say difference, you always take the first minus the second. First number minus the second number mentioned. So in this case, we'll just call it x and y. So we'll translate that as x minus y equals 5. The second sentence says the sum of the larger number and twice the smaller number is 14. Well, which one is the larger, which one is the smaller? Well, if we subtract two numbers and you get a positive answer, that means that first one had to be the larger. So the x has to be larger because 5 is a positive answer. So we're going to take the sum of the larger number and twice the smaller number. So our larger number is going to be x, our smaller number is going to be y. The sum means we're going to be adding, so our second equation is going to be x plus 2y twice the smaller number is 14. The is in both cases, it gives you your equal sign. And there is our system. X minus y equals 5 and x plus 2y equals 14. Okay? So using our substitution method, I'm going to go ahead and take this top one and solve for variable. Just to be different here, I'm going to solve for x. So I'm going to move y over and I get x equals y plus 5. I'm going to take my second equation, x plus 2y equals 14, and I'm going to replace the x with what we have solved here. So, in fact, I'm going to give myself some workspace and come over here to do this. So instead of x, I leave some space, plus 2y equals 14. This is the second equation here. And then I'm going to use what I solved for the first equation and replace that for x. So y plus 5. And then I can solve. I've got y plus 5 plus 2y equals 14. Similar terms, like terms, y plus 2y is 3y plus 5 equals 14. Subtract 5 from both sides, I get 3y equals 9. Divide by 3, y equals 3. That's our y coordinate. Now to get x, we can use back substitution into either equation. X minus y equals 5 or x plus 2y equals 14. Pretty critical that you go all the way back to the originals, because if you've made an error in setting up either of the other ones, you'll happily convince yourself that your wrong answer is still correct. So go back to the originals to plug it back in here. So back substitution, x minus y equals 5. We'll put that 3 in. And then x minus 3 equals 5. Add 3 to both sides. X is going to be equal to 8. So our answer here in set notation is 8, 3. And we can double check that mentally. 8 minus 3 is 5. Yes, that checks. 8 plus 2 times 3 is 8 plus 6. That equals 14. So they do check. The 8 and the 3 checks in both equations. And then there's our answer in set notation. Okay? Now's a good chance to kind of talk through what you just saw there, write down any questions you may have, copy it, review, and then pause the video because I'm about to reveal the answer for this try problem. I'd like you to try on your own. Page 307, number 36. Again, see page 307 in your book if the notes are a little too light or fuzzy for you. In the end though, and this is where you want to pause until you've worked the problem, in the end you should get the system translating to x minus y equals 25, 2x is equal to 12y, and then the solution that you get is 5 and 30 are the two numbers. Where 30 is x and y is 5.